me in the back? Yeah.
This simple phrase and the philosophical meditation that went with it called into question many widely held ideas and beliefs dating back to Aristotle. Ideas and beliefs that were held for over 1,000 years. It took a man of brilliance and confidence to take on Aristotle and the Greek philosophers, and nearly a millennium of tradition. Flash forward a few centuries to today, and we have another man of brilliance and confidence to say that he was wrong. Professor Antonio Damasio's first book, Descartes' Error, challenged the widely held view that something like pure reason even exists at all. That sound decisions come from a cool head, devoid of the heat of emotion, and that surely there were separate and distinct mechanisms in the brain for each of these. Inspired by real patients with damage to their brains that left remarkably reason intact, but devoid of emotions, these patients had profound deficits in decision-making. Attention, aspects of memory, language, math skills, and logic could all be intact, but without emotions, the ability to make simple, let alone complex decisions was gone, leaving these patients hopelessly unable to navigate the world. Inspired by this, Professor Damasio presented a radical idea that perhaps reason required emotion. That while personal experience that we've all had and decades of research has shown that too much of the heat of emotion surely colors our decision-making, perhaps these patients were teaching us that too little emotion could have equally, if not more, devastating consequences. And that all along our journey through life, all types of decision-making in humans is inextricably linked to our emotional world. The second radical idea, and one that personally inspired me, is that the essence of feeling may not be an elusive mental quality, or what philosophers call qualia, but the direct perception of a very specific and personal landscape, our very own bodies. Like many of his ideas, this was contrary to scientific opinion. The somatic marker hypothesis, the basis for Interscope research and many companies in this room, suggests that feelings are the result of a curious and inextricable link between the brain and the body. And that the body, not just the brain, is one of many sources of our knowledge about the world and about our sense of self, including, and most intriguingly, our sense of conscious awareness. And it is this final notion that consciousness itself can be understood only if we understand the interplay between our bodies and our brains that truly begins to break even more new ground and is the focus of his latest book, The Self Comes to Mind. To navigate the minefields of understanding consciousness and to topple 4 centuries of thinking, we need a new science and a brilliant and confident scientific leader like Professor Damasio. As all great scientists do, Professor Damasio revised some of his earliest thinking, so I implore you to take a look at his latest book, The Self Comes to Mind. How does the brain construct the mind? How does the brain make mind conscious? While some of his ideas have evolved, one thing that did not change was the importance of emotion. So quite contrary to Descartes, I think our speaker would agree, it is not pure reason that defines us. Without emotion, we do not have much existence at all. Without emotion, reason loses its force. Without emotion, life loses its meaning. And that perhaps it is not, I think, therefore I am, but that I feel, therefore I am. Born and educated in Portugal with both a medical degree and a PhD, professor of neuroscience and director of the Brain and Creativity Institute at the University of Southern California, he has 4 popular books and well over 200 peer-reviewed papers. He is named by the Institute for Scientific Investigation as one of the most highly cited researchers of the past decade, and it is entirely my pleasure to introduce Antonio Damasio.
Thank you very much for that very kind introduction, and thank you for being here. I was thinking about what to tell you this afternoon, assuming that you probably know quite a lot about neuromarketing, otherwise you wouldn't be here. You have to go to the first slide. Should have a vertical. There we go. Perfect. And I thought that really the last thing I should do is try to give you a straightforward lecture on decision-making or on marketing, because I'm not a marketing expert. I'm just a neuroscientist and a neurologist who has studied a few things that I believe are probably relevant to what I do. So let's start, and I would start with, let me make a few comments as preamble. When you think about what marketing really is, in my own language, it will be something like this. It's the ability to lead an individual to prefer a certain object or idea, and eventually to manifest that preference in the form of actual behavior. Now that preference, of course, could be the result of proper knowledge, proper reasoning, which would be wonderful to think was true most of the time, and that, of course, seems plausible given the fact that we are intelligent and thinking human beings. But the fact is that we are intelligent and thinking, that we're capable of reasoning, but we do not have infinite knowledge, we do not have infinite time. And so it happens that a lot of the time, many of the decisions we make and many of the preferences that we manifest happen without us actually introducing much reasoning or much knowledge at all, although we can introduce them. And it also happens that there's something that people very often forget, and this happens not only in your world, the real world, as well as in my world, which is this marvelous world of science, and even within neuroscience, people forget that we have an inbuilt decision maker and preference presenter within our own organisms before we have any kind of knowledge and before we have very formal modes of reasoning. And that happens to be our system of life regulation. So long before we were able to know, and long before we were able to reason and decide very consciously and objectively on the merits, on the pros and cons of a particular object or idea, our organism is capable of doing so. And even more important and profound is the fact that even before there were brains, organisms were already doing that. So we're talking about something that is not just vital to human beings and vital to organisms that are not human, but even present in life forms that happen not to have brains in the sense that we do in this world. So, what does this lead us to think? that there are systems, and I'm giving you sort of the capsule before I go into details, that there are systems that have quite a lot to do with emotion and feeling, that have preferences, and that interact, that have certain inbuilt choices, and that interact very crucially with knowledge and with reasoning, and that in fact, depending on the kind of thing that you are reasoning about, depending on the kind of thing that you are to manifest a preference or a detestation, we have very often a mix in some proportion of knowledge and reasoning and these inbuilt biological systems that govern your behavior. Okay? So I'm going to start by giving you some beginnings of this, and I'm going to show you a few brain images. And there are a few brain images that are here for a purpose. I want to call attention to a couple of facts. So let's start on this. You're going to see, if it all works away, you're going to see a skull that is going to be peeled off, and it will reveal a brain. Obviously, I don't need to tell you that today we have enormous possibilities with brain imaging, whether it is structural, as you're seeing here, or functional, and you're seeing a real human brain. But the thing I really wanted to focus on is the fact that there's not just the telencephalon with its cerebral cortex, but hanging down from it, there's this thing called the brainstem. And it passed very quickly, but I'm going to come back to that brainstem, and I want you to think of this fact, that for reasons that have to do with the development of neuroscience, people began by understanding the cerebral cortex, and then they continued understanding what was underneath the cerebral cortex, a variety of nuclear structures underneath. But it so happens that the cerebral cortex and the other appendages are in fact not the leaders of this process, but are in fact the result of this other set of structures in the brainstem needing to have, given our complexity, a helper to navigate life. So one thing that I would like you to take away from this talk is that what really sets the agenda for what we do in our daily life, whether it is choosing to go to a restaurant, or what you're going to buy in a store, or how you're going to decide on your investments, has to do first and foremost with life regulation, with one that we can call homeostasis. And that homeostasis can only be well regulated in a system as complex as ours, in a world as complex as ours, if you have something that has been added on to that basic system, which does include the cerebral cortex and many of its underlying nuclei. So I'm turning the picture upside down, which is the way I think it should be. Now, I'm not going to tell you that the cerebral cortex, on which in fact most of our knowledge and reasoning, conscious, deliberate reasoning is based, I'm not going to tell you it's not important. Of course it is important. I wouldn't be here talking to you about my cerebral cortex, and you wouldn't be listening without it. And much of what has been achieved in our civilization depends on the existence of that cerebral cortex. But it would not have made any sense at all in evolution if it had not been developed for the purpose of governing life first and foremost. That is the fundamental purpose. And how are we going to understand how this thing works up here if we don't know the purposes of the machine, and if we don't know what that machine is serving, is of course a very thankless task. The other thing I wanted to bring out again in this with a series of pictures is that for perfectly reasonable causes, we have concentrated on the cortex, and we have concentrated on the many modules that we know now from neuroscience do a variety of tasks. But it so happens that underneath that cortex there is the reality of connection systems. So if you have a region in the frontal lobe, the temporal lobe, the parietal lobe, that is doing a certain job, that is helping you make a decision, for example, that region is going to do that not by itself, but in cooperation with other regions. And guess what? In order to do that, it is important to have connectional systems that join up the regions and literally function, in a very paltry metaphor, as phone cables within our own brain. And there are millions of them. In fact, we know that we have billions of neurons, and many of those connections are made of axons, they're made of fibers that come from a cell body, a neuron cell body, and go to another region. And I'm going to show you a few pictures of that. So again, you have a brain, the brain is going to be peeled away at the level of the cortex, and you're now looking at that connection system as revealed by magnetic resonance. And by the way, the colors have a meaning. The green colored fibers correspond to back to front or front to back fibers. The blue have a vertical position, and you can see them going all the way down to the brainstem, and the red ones come across. And now you're going to get a couple of other views to see how beautiful and complex it is. Keep in mind that we are, for purposes of representation, not putting all the millions of fibers available, but each of those lines represents a considerable bunch of them. And I'm going to show you as we exit that the corpus callosum, which is this middle structure that joins the fibers from both hemispheres, and finally you just show the ones that cross in the corpus callosum, which are shown there in red. Okay? So, let's give a biological context to all of this and let the show go. I mentioned that word homeostasis, which is really an equivalent to life regulation, and I want you to have an idea of why I think this is important. Homeostasis, life regulation, is something that exists in every living organism, including ours. The immediate goal of life regulation is management of life. It's really the role of a manager. Energy procurement, metabolism, all of those are basic functions that have to be regulated by that function. You need to maintain the integrity of the body. That's part of homeostatic regulation. You need to ensure species continuation. And you need to have social regulation. This is very important because when you are in a field like marketing, it is eminently social. This is about how you have human beings leading others to do certain things, convincing them that certain things are preferable or not. So that's part of social regulation, and social regulation is part of this basic homeostasis. And again, if I can help you with an interesting idea, don't think of social regulation as something that exists in human beings only, or that exists in monkeys and a few other primates. Social regulation is pervasive across the entire life scale. In fact, even bacteria have social regulation. So we're not talking about novelties that we developed with our great big cerebral cortex. We're talking about fundamental principles of life regulation. Now, of course, these tend not to be thought about, they tend to be forgotten, which means that we get a very perverted picture of what we really are and living creatures are. Okay. The goals of homeostasis are implemented via action programs. This is something that we need to know, because if you don't know this, you're never going to understand what emotions are all about. Basic action programs solve complex problems with standard but elaborate responses that do not require deliberation. So think of the beauty of this. We are born with systems that will apply a certain action program, not a reflex or two reflexes, a complete action program to solve a problem that is important for our life. And this is done without you having to think about it, because you're not going to think about regulating your temperature up to a certain point. At a certain point, you're going to feel cold, like you do here, and you're going to put on a coat, and that is a very important signal. But, you know, if you're a small animal, you're not going to put on the coat, you're going to do other things, and that is all built into the program. The animal is not going to have to decide whether to put an overcoat or a raincoat, okay? So, think of the fact that these are action programs. The basic homeostatic programs are preset, so they're innate, they're instinctual. Although learning, of course, can expand the scope of these programs. And the socio-cultural homeostatic programs are developed by humans, but shaped by basic programs. So when we talk about a social-cultural program, then that really gets us into the realm of humans. So if you have something like economics, or politics, or moral systems, or justice, or religious systems, or something like marketing developments in the world of finance or industry. That is a sociocultural program, and that is something that is definitely outside the realm of non-humans. But that is something that, and here's the beauty of it, is developed on the shape of what was in our system to begin with. Okay? Next, varieties of action program. This is that gets closer to you. You have drives, you have motivations, and you have emotions proper. So the reason why I'm so interested in telling you about action programs is that emotions are action programs. They're sequences of actions to achieve a certain goal. And of course you have drives, like for example, if you are thirsty and you need to drink, which is what I'm feeling right now, or if you are motivated to eat, or if you have desire, sexual desire included, desire to buy a new suit, all of those are, in fact, action programs. So you have appetites for food, drink, sex, exploration and play, care of progeny, attachment to progeny and mates. All of those are sequences of actions, and you have nothing to do with how they were implemented in your brain and how they are executed. You can shape them once you know what's going on, and you can put, for example, a stop on something that you or society finds morally unacceptable. Or you can do, on the contrary, you can push it forward if you or society find it conducive and helpful. But the way in which it began is entirely given by the system. And by the way, exploration and play are a very important part of this story, and very often forgotten. And in fact, in your field, this is most important because playfulness is not something that you develop and may or may not be important. It is very vital for development of humans. It's very vital in childhood, and it continues to be. And the reason why, for example, you have the enjoyment of music as you just had, or the reason why people flock to entertainment all over the world, and it is a very important industry, is precisely because play is important, and fantasy is important, and we indulge in it in one way or another to a greater degree or less. So, the emotions, I have them there on the list. You're familiar with this, I'm not going to bore you with it. I just wanted to make one particular point there, is that there's a group of emotions that is very basic, and it's involving basic homeostasis, and things like disgust, fear, anger, sadness, grief, joy, and happiness are on the band of those basic emotions. And then you have this other group separated by the space, which are what I like to call emotions related to social homeostasis: embarrassment, shame, contempt, pride, compassion, admiration. These are emotions. They have their own action program. They are fundamental. They appear in the system, certainly in human systems, and some of them even appear in animals before they appeared in humans. But think of what they mean. Embarrassment and shame is not about food, and is not about desire necessarily. It's about a judgment that you are making on your own actions that leads you to be ashamed. Or contempt, which is a judgment you're making on someone else's behavior. Or pride, or compassion. All of these exist as routines, as action programs to begin with. Okay? So this is what you have to work with in your field. It's what I have to work with in my field too, because I want to understand why and how this works. Okay. An example, again, I suspect that with your knowledge, I think you probably read quite a lot of neuroscience, and you probably know a lot of this. Take the general action program of fear. You have preparatory actions on the heart, the lungs, the gut. You have analgesia. You have secretion of hormones like cortisol. You have strategic behaviors. You can freeze in place or you can run away. You have attentional behaviors. You can attend to a particular object. All this to tell you that this is really not one little reflex. This is more complex than that. It's a concert of things that happen in time and very rapidly. Now, where are the command units for the execution of these action programs? And they are located in specific brain regions. And I'm going to give you the example of two of them. One is the periaqueductal brain, PAG, and the other, which is in the brainstem, and the other is in the amygdala, which is in the telencephalon. And you have there that little cartoon that shows you the amygdala on one and the region where the PAG is located. Again, just to make the point that these things are subcortical. This is not coming from the top of the machine. This is coming from the basement, okay? And you know, I have those little rectangle and square and circle, but the world that we have underneath is huge. So when you look underneath with powerful magnetic resonance, or with magnetic resonance combined with neuroimaging, you can see the world of these nuclei and what they are doing, and they are, in fact, a very complex world. Now, the deployment of action programs can be triggered either by an internal condition, for example, thirst, hunger, or by the outside world. For example, when you perceive certain things that lead you to be fearful. Now, the brain sensory systems survey both the internal state of the organism and the environment. This is absolutely critical to make sense of this story. So, our brain, in keeping with what I told you at the beginning, our brain is constantly monitoring not just the outside world, which is what people think about first, because we are so dominated in our life by the outside world. But our brain is monitoring what is inside. And guess what? Feelings are going to come out of the monitoring of what is inside, even if they can be caused by the outside. Okay? If you understand this, you understand one of the profound things of neuroscience, which unfortunately many people have not understood, including very good neuroscientists. Okay, so the results of deploying an action program is registered within the brain sectors concerned, surveying the state of its body. And I just would like to call your attention to this beautiful slide. This comes from a very recent study. It was published a month ago in Proceedings of the National Academy of Sciences, and it comes from a very good group in Finland, in Helsinki. And what they did was study the distribution of body activities, which corresponds to my notion of action program, because this is what inspired it, and the distribution in different emotional states. So you can look there and you can see how anger or fear have a different distribution, how happiness is so completely different from anger or fear, or from, for example, a depressed state, but has actually quite a lot to do with the state of being in love, and how things like shame or sadness or pride have, again, a different body distribution. But what is the interesting here is that the right sequence is action program, leading to body being notified, leading to you perceiving that body, which gives you the purchase or what the feeling is. So when you are aware of being in a certain emotional state, what you're really seeing is the feeling of that body state that is caused by the emotion. So, in example, in the case of an emotion caused by an external situation, part one of the process is the perception of the situation, the classic story of the bear coming to you and frightening you. Part two is the actions that respond to the perception. You have the action program to be frightened. And part three is the perception of the internal transformations of the body, which results from part two. The third and last is the perception of the engagement of the action program, which becomes the feeling. And of course, feelings correspond to all of the possible emotions that you can have, and the body states that are regulatory. That's why there in the example I have thirst, hunger, desire, pain, joy, sadness, admiration. What have you, anything that changes your body and has a regulatory role is going to be a feeling. Why and why do feelings arise? Homeostasis requires the sensing. So the reason why this all came about is very interesting, is that because you could not run this machine without sensing what the consequences were of what the machine made you do, then it was necessary to sense. And once you sense, which can happen both at the level of cells and at the level of systems, then feelings result. I'm not even going to try to tell you what we now know about the cellular level, which is huge, but that's actually not relevant for what you do. So these descriptions become the mental contents of feelings. feelings, and feelings are, of course, mental experiences of the deployed action programs. What are the consequences of this? Several things that are important. Number one, feelings force attention on the body conditions that cause them. This is very important because you could say, well, who cares if you have feelings? I mean, you have the action program, so you've got what you wanted. You have an action that serves the purpose of protecting you, so why would you also need to feel? Well, you need to feel because by feeling, you can pay special attention to an object and therefore enhance your chances of continuing on to proper behavior. And also, you have the chance of learning what is good and what is bad. And this is where, by the way, the world of decision-making relies on, and the world of marketing will rely on as well. So it's through feeling that you become acquainted with what is really adverse to you or what is advantageous to you. So feeling is in of itself an important level above the level of the emotions. So to talk about emotions alone is not sufficient. And of course, all of this is very important for what? For anticipation of future behavior. So why should we devote, for example, as neuroscientists, so much effort to feelings and to their origin and use? One aside, and this, by the way, my introducer was kind enough to point this out, is that this has quite a lot of relation to consciousness, because in fact, the world of mind and of conscious behavior and of social behavior has quite a lot to do by relying on feelings. Feelings contribute to our consciousness. And there are pathologies of feeling that in fact dominate medicine right now. Think of depression, pain syndromes, and addictions. All of these pathologies are pathologies of feeling. People being depressed is about feeling sad, first and foremost. Pain is a feeling. And likewise, addictions are entirely manipulated by cycles of pain and need and the good results emotionally and feeling-wise of taking drugs, and then, of course, the consequences of all that by another dip once the effect is over. So, again, this is not, it may appear like a very esoteric intellectual subject, and I'm afraid it is, but it's also very practical, not only in your world, but in the world of human beings. And how on earth one can understand human beings without understanding feelings and why they are, I don't know. It doesn't make sense. And how we can understand consciousness without understanding that the first thing we were ever conscious of were feelings, again, I don't understand. Okay, so what do we know about the brain behind feelings? Again, very quick. Do you like to look at pictures of the brain? I can skip through this at fast speed and save you the trouble, but I'll just show you. Again, for those of you who are interested in this literature and have read a lot of the papers, you probably have heard about the insular cortex, the insula, and you have heard that that's where feelings come from. By the way, I was one of the people that said that, and so I'm responsible for it, and I was right. The insula is, in fact, involved in feelings. And the long and the short of the story that I'm going to tell you next is that it's not the insula alone, and that the insula was, in fact, what we concentrated on first because it was bigger, because it was more available, and it's because where you could go first. But, in fact, feelings depend on structures at other levels. And you might say, how on earth do you know that? Well, we know that from different kinds of evidence. One that tells you there are activations of brain structures beside the insula when you're having feelings, and that's helpful. And the other is that we can remove the insula, as nature does when we have certain brain pathologies, and the insula gets destroyed on both sides, and lo and behold, the patients still have feelings. So clearly, although the insula is involved in feeling, it is not the only structure that is contributing to your ability to feel. So I'm pointing there the insula for you. We have one on each side, so the brain bears an imaged brain of a real person, of course, it was scooped out so that you see that the insula, which, by the way, signifies island, is there as an island, as cerebral cortex, but underneath the cerebral cortex. And it has a variety of gyri. You don't need to know all those details. There's an old part and a new part. The old part, the one that is in pink, is actually the one that is most concerned with feeling. And important thing is that if you do functional imaging and you ask yourself what happens when you have feelings of sadness or happiness, for example, or in fact anything else, sexual desire, hunger, thirst, pain, you name it. What happens is that the insula gets activated. And this is actually the first study that was done on this. This dates now back to 2000, and with PET scan we demonstrated that, so when you are sad, in fact you have bilateral two-side activation of the insular cortex. And if you go to happiness, here you have exactly the same thing happening. That the insula is activated, not exactly in the same spot, but it is activated. So that's no doubt that the insula is critical for feelings. However, after you have damage to the insula, and there you have the top row is a row of a normal brain. The second row is a damaged brain. The third row is again another level of the same healthy brain. And the bottom one is the brain, again, of the patient that was in the second row. And the insula is marked in the continuous red ovals and is perfectly intact in row 1 and 3, but it is not intact in rows 2 and 4. And it's a dotted red line. In fact, it's a void because the damage in this brain destroyed. So this was actually the first case in which we saw this. There are several other cases. And if you have damage in this area bilaterally, the patient still has feelings. There's something that the patient does not have, which I will tell you in a minute, but feelings is not the problem. If you look at what happens in that same patient to the region of the basal forebrain, which is also involved in emotional and feeling processing, that region is gone except for the nucleus accumbens. How many people in the room are interested in the nucleus accumbens? See? I'm glad to know. If you know about the nucleus accumbens, you are a good audience. You pass. You don't need to know anything else. So the nucleus accumbens is the structure in red, and you can see that the patient has, in fact, preserved the nucleus accumbens, although the parts of the basal forebrain, which is marked in green, is largely gone. Now, feelings also survive bilateral damage to the anterior cingulate cortex. So if you damage the anterior cingulate cortex, which is, again, vital for the process of emotion and feeling, you still have feelings. So what happens is that these patients have a preserved brainstem. And when you look at the brainstem level, which is there in yellow ovals, you see that the brainstem of these patients is intact, and the presumption is, on very good grounds, that the brainstem is supplying what the upper structures no longer do, but probably for the very good reason that it was the structure that to begin with was in charge of this. Why do we even have such a hypothesis? If you look at that schema, just to, in very, very plain terms, to explain to you that when you have information about the body state, in order for you to have, for example, in your brain, up there in the cortex, information about what is going on in the body the same way that you have in those pictures of body states and emotion, you need to send signals first to the brainstem. There's no way of sending the signals from the body, from your head, from your face, from your legs, or from your heart and abdomen. You cannot send that to the cerebral cortex directly. It needs to go first to the brainstem. Whether it goes from the spinal cord or from the trigeminal nucleus very high up, it goes first to the brainstem. And it lands in nuclei that you don't need to know about in detail, but include the parabrachial nucleus, PB, and the MTS, which is the nucleus tractus solitarius. And it is from there, after the information is processed in an extremely complex set of nuclei, that further signals are sent upstairs to the cerebral cortex, to amygdala, and to a variety of other telencephalic structures. You have this schema, which
sort of pares down the complexity just for you to see the ring. Even when you pare this down to those 5 different structures, you have an extremely complex computational model. And you have something that also happens and has been repeated beautifully at cortical level, which is that when you go from structure A to structure B feeds back to structure A. So you have, in fact, loops that are convergent and divergent among themselves, which means that the system is fully integrated, okay? And it is after beautiful things are done here, decided and processed, that we can send signals upstage for further analysis of the process. Okay, so the way we would put the conclusion is the following. The upper brainstem provide the first full organism integration of body states available to the central nervous system. So it's there, it's not at the level of the spinal cord, or it's not lower down in the brainstem. It's at that level that is very high, that your brain first gets to know and get a map, get a representation of what on earth the body state is at that moment. This is a very important point. Second, the insular cortices, of course, are not useless. Otherwise, we would not get the effects we do. The insular cortices provide several things. First, a more explicit map of feeling states than the brainstem can provide. Why? Because the brainstem, while extremely complex, is limited in size. There's a certain scope of that structure. And the other thing is that the brainstem is very far away from the cerebral cortex. So here we have this beautiful machine where we have knowledge galore, memory of the past, memory of the things we're working on, the possibility of imagination, language, the possibility of making reasoning over different facts, perception, high-level perception, visually and auditory. So you have this very complex world, and you definitely want to have an interaction between the world of emotion and feeling down below and that world of high cognitive ability. And the insula happens to be the best platform for that. So what the insula is providing is what the brainstem provides, but it does so higher up, and it does so in a way that is more conducive to rapid interactions with how you reason. So if you were to ask me, when you manifest a preference for something that you have seen or something that you have heard, it is quite likely that although there's this chain of processing coming up from the brainstem, there's certain maps that are going to be preferentially involved first, and then the rest of the system may be involved, and the insula may be called upon to do that. So there's no question that it's going to be important. And if you rob the system of that top level of feeling, then what you're going to have is enormous difficulty in making the connection. And so when I told you that those patients that have damage to the insula have feelings, and I told you there is something wrong with them, is that they can't use their feelings to make any decision. So their feeling is fine. They can report if they are happy or they're in pain, if they have hunger, etc. But they cannot connect that with the decision-making system in the proper way. So something has been lost, and it's quite important. And especially when you think about social behavior, in which your activity is included, that would be a big problem. So let me just turn around in the last minutes to talk to something else, which is the application of a lot of this knowledge over the past 20 years to the somatic marker hypothesis. Somebody else the other day said, you mean somatic marker hypothesis or somatic market hypothesis? So this would be familiar. If you want to call it the somatic market hypothesis, as long as you don't tell it to my face, that's perfect. So what does the hypothesis say? And I reworded it for your benefit. I hadn't actually talked about somatic marker hypothesis in a long, long time. And so instead of talking about emotion, I'm talking about homeostatic processes play a role in decision making. I don't think there's any question about that. That's what people do even before they think, and that's what people still do when they're thinking, aided by homeostasis. Consciously, this happens in the form of gut feelings. And non-consciously, it also happens by biasing decision-making processes. So what do I mean by this? So if you are trying to contemplate a choice, and clearly the elements that you're contemplating have different values emotionally for you, they do for everybody. What is going to happen is that independently of how you analyze what you know about the objects, what you know about the process behind it, you're going to have a reaction to that particular object in a way that may be entirely non-conscious. You will not know that it is happening, and what we'd like to call that is a biasing. What does that mean? It means that the system is going to favor that, is going to give it more representation, is going to give it more oomph, is going to give, for example, more projections available of a particular neurotransmitter that will make you feel better about something. The interesting thing, though, is that that feel better may not be known to you. The system may be on the way to making you feel better, but it doesn't follow that you actually feel better. It may be just biasing it at a non-conscious level. So this is something that if you think at your own behavior, you know that this is happening to you. And there are many ways of investigating this and investigating that non-conscious signal, but it is something that may not come to consciousness, or may come to consciousness after you've made the decision. And by the way, it may come to consciousness and it may actually be misleading because you may be making a false interpretation about what happened. Now, a lot of the time, and this is very classic, you actually have a feeling that you can report. And that's when people talk about a gut feeling. I have a gut feeling that I love this, or I have a gut feeling that I'm frightened and this worries me and I'm not going to go there. Okay? So then at that level, you do have consciousness because the feeling in of itself has to be conscious, or otherwise you should not even use the word feeling. I don't like to use the word feeling for non-conscious processes. Let's try to make these as clean and hygienic as possible. If you feel, that's a conscious process. Now, what may happen, though, is that you may feel in relation to a situation in which you're being asked something, but you may not be aware of the relationship to the feeling. So what you're having is a feeling, you're conscious of the feeling, but you don't know why you had the feeling. This happens all the time. People are constantly in the middle of a party and feeling suddenly well, but they may not know why. And it may come to them later. And again, that may be a correct interpretation or maybe complete fiction. So the important point here is to realize that we have many layers of operation for this machine that is helping you think through the world and navigate. And one is that it is totally non-conscious, and there's a biasing of the incredibly complex neuronal process. Another, that it is conscious at the level of the feeling, but you don't know why you have the feeling. And the other is that you have the true gut feeling that, yeah, I have this gut feeling that tells me I should not do that. Okay? So these are very different things. And by the way, let me point out something. Sometimes people say, well, but isn't it true that emotions are disruptive? Why would you want to guide yourself by these things that happen in the middle of this process of decision? And one thing that is very, very important is to make the distinction between the kind of emotions and the kind of feelings that are integral to the problem and the kind of emotions and feelings that are extraneous to the problem. So, for example, if you are in the middle of a decision and suddenly there's an incredibly unpleasant noise that irritates you, That will be disruptive to your decision making. But it has nothing to do with the fact that you're deciding on whether or not to buy stocks of X or Y. It is something external, and in fact it is disruptive, and you should avoid it. And that's when you can talk about emotion having a negative effect. But within the compass of the decision-making process, emotions and feelings have by far more positive than negative role in terms of achieving a particular result within the parameters of who you are and what is at stake. Just another one. So what is this marker? Not the marker, the marker in the somatic marker hypothesis. It's really a memory. And it's a memory of a trace that was learned in past experience and is recorded in structures. For example, it could be the ventromedial prefrontal cortex, but not only. It could be in the amygdala. It could be in a variety of other cortices that can hold a memory of a certain conjunction. So the marker signals the conjunction of a certain category of situation or outcome with an accompanying homeostatic response. So it is that joining of these things that stays in memory and that I like to call the marker. And I chose the term somatic exactly because this is so linked to body processing that it makes sense. And final point, it's the representation of a given situation that reactivates the marker, which in turn replicates the respective homeostatic state and weighs on the decision process consciously or not. This is extremely important because what we're going through in our lives, precisely because we have memories, conscious and non-conscious, is that we are constantly finding situations that formally are similar to other situations in which we have been in our life. And because of that, we have a chance of constantly reactivating these signals, whether we want them or not. And it is because of that reactivation that you're placed in a certain set. Now, of course, the advantages of this are incredible because, given the fact which I pointed out in my first words, we do not have infinite knowledge. And by the way, one of the things that happens to patients who lose the possibility of using these systems, for example, with frontal lobe damage, is that they are relentless in trying to go around and around a problem, not being able to come to a clear conclusion. And that's because they have limited knowledge and they keep going on and on, trying to find a way to solve the problem, to have calculus, instead of going more quickly to the result by having a signal that is emotional. Now, of course, we all know that that signal can be wrong. We can be very poorly advised by our emotions and make the wrong decision. But within the compass of the decision process, the signal is important because it saves you time, precisely because you don't have all the time in the world and you don't have all the knowledge in the world. So it's an aid to your system. Okay? And I just brought that classic image of one of the systems in which damage will more clearly produce this result, and that's prefrontal cortex, and it's more medial and ventral, so it's more in the middle, in between the hemispheres, and more in the bottom part of the frontal lobe. And it is lesions like that that very often cause these momentous problems of decision making. And I think I will stop there because you've listened to me very patiently enough, and I just wanted you to have an idea that what you're doing, I think, is very well anchored on human biology and biology in general, and that if there is, in fact, as we seem to find, all this system of preferences and guidance of our behavior by things that are clearly of an emotional and feeling kind, that's not chance. There is something that is entirely integral to who we are as biological creatures. Okay? Thank you for your attention.
Ladies and gentlemen, on behalf of the board of the pleasure and enormous honour to announce that Professor Damasio has been good enough to accept honorary membership of the NSMBA. I'm coming to that. I should say this is the first, number one, ticket holder, the first honorary member of the NSMBA, and I cannot think of anyone for whom this award is more appropriate. Professor Damasio's work has transformed our understanding of the role of emotion in decision-making in a profound manner. And I really don't think I can improve on the outline that Dr. Karl Marcy gave of the impact of Professor Damasio's work in this area. So it is without any further ado that I would invite Professor Damasio to accept honorary membership of the NSMBA. Thank you very much.
Thank you very much.
I will make it short because I know some people need to catch planes. I need to thank a few people, starting with speakers who made this tremendous forum possible, with the NMSBA board, of course, who were here able for all the days. I would like to thank in special the Masters of Ceremonies, Pranav and Carl, who did an excellent job of time management. I need, of course, I also would like to take the opportunity to thank all our sponsors who made this possible, and especially the Ipsos stint and Elisa Moses as the local chair of the United States. I also really want to thank you, the audience, who were so friendly and enthusiastic, and that really made the conference cheerful and happy to me. And last but seriously not least, I need to thank the NMSBA team who worked literally 60 hours this week to make this all possible. And I also want to mention Femke Sandberg, who delivered the baby, and she's at home, but she is working on all the incoming emails away. So. Excellent job, thank you very much. Right. Now there's a small announcement. I invited you to come over to the capital, the neuromarketing capital of the world. And as you might know, it is a moving capital, so I'm sorry, dear US citizens. We are taking this capital with us, and maybe you are curious where it will be. I can tell you, I know where it will be. The next Neuromarketing World Forum will be in March 2015 in Barcelona.
Woo!
Thank you. Enjoy the drinks.